Hello YouTube. I didn't go over a delete all instances of a node function in my last video, so I want to do that in this one. Um, this one we're going to input a key, kind of like delete the first instance, but we're going to delete all instances that have that key in the as value in the node. So this is going to be of type node void, sorry, and then delete all instances, which takes in an int key as a parameter like the last one. We're going to have a current pointer of type node, which is equal to the head. This is just so we can traverse through the linked list. So while current does not equal null PTR, so while there's items in it, if current's value is equal to the key. So if what is it? Oh, sorry. So if our current let me just write this down. 2, 3, 4, 5. So if our current, say our current is 2. So if our key is 2 and our current is at 2. So if current value, this is our 0, 1, 2 third node. So our third node's value is equal to the key, which it is. We are going to say we're going to do another node pointer called node to delete. Node to delete is equal to the current. So we're just going to use this as a placeholder to so we know which node to delete. Here we want to, now we're going to unlink one's next from 2, and then 3's last from 2 as well. So link it to 1 to 3 instead of 2, and then 3 to 1 instead of 3 to 2. So we want to check if node's last is null, because if it is null, that means it is the head. So if current last does not equal the null, if current's last is not null, we're going to say current's last next is equal to current next. So essentially what's happening here is since we want to delete 2, we check if current's last is not null. What is current's last? It is 1. 1 is not null, so this is true. We go into here, current's last's next pointer. So current's last is 1. 1's next, we're going to point it to current's next. So we're going to do this. We're going to point this right now. So this is at 1. We're going to skip it all the way to 3. So now 1 is pointing at 3 instead of 2. And then we do an else statement here. If it is if current's last is null, we're just going to say head is equal to current next. So here, if this was our node to delete, we would since current's last is null, this is null right here, null. This condition isn't true, so we just skip to here. Head is equal to current.next. What is 0's next? 1. So head is our new 1 is our new head, sorry. And then now this is just linking it from one way to from left to right, right? It's from here to here. Now we got to do it back from right to left. So we check again if current next isn't null. So it's the same idea as this top one, does not equal null PTR. we're going to say current's next last this time is equal to current last. And then again in our else statement, did I spell that right? No, I didn't. Else tail is equal to current dot last. So here, if current next, what is, and back to our example, 2, we were looking for 2. 2 is our current. Is 2 is 2's next pointer null? Is pointing to 3? Null? No. This is true right here. So we go into current, which is 2. So current's next last. So 3's last is equal to current last. So we're going to point 3 to 1 now. So in this one, in this top one, we are pointing 1 to 2's next, so 3. And in this one, we're pointing 3 to 2's last, which is 1. So essentially just doing this is what we're doing. Boom. So we're not, now we're unlinking it from 2. So then we want to keep on moving through the linked list. So we say current is equal to current next, and then we delete the node to delete. Now this is only if the conditions are met. If it is not met, we want to keep on cycling. So we say else current is equal to current next. Here we go. Right? So let's restart this. So let's make some more nodes. You have to do this too as well. Node 4, node 5, node 6, and node, we'll just use 6, delete this one. We can call this 0, 4, and 0. 3, 4, 5, 6, node 6, delete this one. Now we want to, let me comment this out. We're going to show that it works. See out, deleting. I can't spell, man. Deleting all instances of 0. And then we want to call list dot delete all instances, and then we want to put 0 as the parameter. Then we say this our new linked list. List.printlist. So here we go. As you can see, our linked list currently is going to be 0, 1, 2, 3, 0, 4, 0. We run it. 0, 1, 2, 3, 0, 0, 1, 2, 3, 0, 4, 0. Deleting all instances of 0. New linked list is now just 1, 2, 3, and 4. So hopefully I like the way I showed you guys this function. Let me know if you understood it, or if you need anything to be clarified. I'll try my best to help explain it. Yeah, thank you for watching.